Hi there, welcome to KMC Sizzlin' Summer Online. Even though we aren't able to do on-site classes this year, we're still doing our best to keep you all learning and having fun over the summer with some fun and easy to do science experiments and demonstrations. Today we're covering a special thing called the Magnus Effect. So, what are we talking about when we say the Magnus Effect? What is it and where can we see it? Well, the Magnus Effect is all about air pressure and how if something spins fast enough, it can generate lift, which is just another way of saying flying. If you've ever wondered how a pitcher in baseball can make a curveball instead of the ball just going in a straight line, that's all using the Magnus Effect. So, how does the Magnus Effect work, you may be asking? Well, I'll tell you. You see, it's all about air pressure. For the Magnus Effect to work, the object needs to be round, like a ball or a cup, and it needs to be thrown with backspin, which is to say that the top of the cup as it spins is pointing towards where it was thrown from. As it flies through the air, the friction between the cup and the air creates drag, which pushes and pulls the air around it. The top part of the object is spinning backwards, meaning it's speeding up the air on top, creating an area of low pressure, because as air goes faster, it has less pressure in it. The exact opposite thing is happening on the bottom, where the drag from the rotation of the object is pushing towards where the object's going, causing the air to slow down. That means that the bottom of the object has high air pressure, while the top of the object has low air pressure. And what we know about air is that air wants to have the same pressure all around, and it will move things in order to create a pressure. So, what the object is going to do, since it's created an area of low pressure on top and an area of high pressure on the bottom, is it's going to move upwards because the air around it is trying to make all the pressure the same. Now, to conduct this experiment at home, what you're going to need is two paper cups. They have to be the same cups. A bunch of rubber bands, usually 2 or 3 will work, and some tape to hold those cups together. To build your experiment, take your two paper cups and put the bases together. Wrap some tape around there about 2 or 3 times, just enough to make it strong. Once you've done that, take 2 or 3 rubber bands, however many you think will work, and tie them together at the ends. Once you've got that assembled, you can start to wrap that rubber band around your cup. Make sure you stretch it out as you're wrapping it around so that the rubber band is under tension as you're winding it. Once it's wound up, be sure to hold the rubber band like you would when you're shooting a rubber band off your thumb, except on the back, you're also holding the cup so that the rubber band comes out from the bottom side of it. If you're having trouble figuring it out, just copy what I do in the video.
Now that you've successfully made a paper cup flyer, let's see how much further we can take this experiment. Try different size cups and longer rubber bands, stretching them at different lengths. See how that changes the flight of the object. Do you think bigger cups will make it fly for a longer period of time, or do you think it'll just make it go higher? And lastly, see just how big you can get the experiment to go. Do you have maybe a big KFC bucket, or something that large? How big do you think you can get the object so that it will still fly? Now that you know more about the Magnus Effect, I encourage you to go out and do more experiments. See just how curvy you can make a curveball. If you're a little more on the building things side of experimentation, I'd encourage you to check out all the different Magnus Effect based RC planes that are out there. The YouTubers Peter Stripple and Essential RC have really in-depth videos on how to build planes like this. Well, this experiment can be done for very cheap at home. Some of the later experiments that KMC will be putting out may require you to purchase things. If you have trouble purchasing them, be sure to contact Dr. Tanoff or the rest of the KMC staff, as we may be able to provide financial assistance.